Welcome to our discussion on proportions and percentages, or more specifically, just more work with fractions. I know a lot of students hate the F word, but proportions, percentages, ratios, those are all just fancy words for other uses of fractions. So proportion is a fraction of a whole, right? So there's that word I told you, it's a fraction. And then percentages are just kind of a special classification of proportions where the denominator is always 100. 50%, per means per 100. So 50% literally means 50 divided by 100, which would be 0.5 as a decimal or reduced to 1/2 as a fraction. But the reason why we deal with percentages is it just makes it easier to compare amounts, because if you're trying to compare 2/3 and 5/8, most people have no idea which one's bigger. But if you convert them both to percentages, it's very obvious. It's the same thing if you convert them both to decimals, because really percentages are just decimals with a fancy little symbol at the end of them. Okay, so let's look at the following information. And then the proportion of mid-sized cars, right, is how many mid-sized cars there are over the total. And then we would want to reduce that as much as we can. And then we could take it even further and list it as a percentage. So really all you're doing is taking a fraction, put it in your calculator, spit out a decimal, convert that decimal into a percentage, which means just move the decimal places 2. Now, it's the same thing as multiplying by 100, but technically you're just shifting that decimal place over, right? That's the shortcut. So here's another example. See if you can change that to a percentage. And hopefully you can see that it's very simply just 32.05. If you do it in your calculator, you're going to get 0.3205, which becomes 32.05 as a decimal. Here's another example where we can figure out the proportion, right, of adults reporting having a college degree. So wouldn't that just be 373 out of the total 1,002? It's going to be roughly 37% when you figure it out. But when you do the math, you can get the exact amount and see that it's 37.23%. How about if we can use proportions to find some quantities? They tell us the proportion of people who are left-handed is approximately 1/11. If there are 45 people in a room, we can estimate how many of them are left-handed based on this given proportion. So we can just basically figure out 1/11 of 45, which gives us 4.09 repeating. You can't have 0.09 of a person. So you would kind of assume that in a room of 45 people, there should be roughly 4 of them are left-handed. How about an example where we work with both ratios and percentages? And the only reason why we want to be able to convert back and forth between these things is so that we can compare apples to apples and oranges to oranges. Because if they tell you, for instance, if you remember one of our previous examples, that some university had a new incoming freshman class with a ratio of 2 to 3 men to women, and then they tell you university-wide, so for that same university, 53% of the entire campus population is men, the question might be, is the proportion of men in the freshman class different from that of the men campus-wide? So it's 53 campus-wide is 2 to 3, roughly 53%. And hopefully you know right off the bat that that's not roughly 53%. It's got to be less than 53% because there's 2 men for every 3 women. So it's less than half men right off the bat. But we can actually do the conversion to see just how different it is. So working with that proportion, we know that if we have a 2 to 3 ratio, that means for every 2 men, there are 3 women. So out of 5 total students, right, 2 plus 3, 2 of them are men. So that means 2/5 of the incoming freshman class is male. And if you turn 2/5 into a decimal, you get 0.4. And if you turn that into a percentage, you get 40%. And you can see that 40% is quite a bit lower than 53%. So it looks like that incoming freshman class is disproportionately low for male based on what they had in the past. So maybe they need to change their recruiting process. Here's an example that might come up in a science class, right? We know that the Earth's core makes up about 31.5% of the Earth's mass. The mantle makes up the other 68.1%. And then even though the crust is 20 to 30 miles thick, it only makes up a very small proportion of the mass basically 0.4% of the total mass of the Earth, which is this big, huge number written in scientific notation. You know that 10 to the 24 means that you're basically multiplying this by 10 24 times, or you're moving this decimal to the right 24 times, and you're going to have a whole boatload of zeros at the end of this thing, and it's a really, really big number. Okay, so here's a visual picture of what we're talking about. We're looking at this little tiny crust at the top. And if we want to figure out how much it weighs, all we have to do is take 0.4% of this total mass. And the nice thing about scientific notation is you can actually work with it that way, right? Because scientific notation is literally multiplication. So this is this number times this number, and then we're going to multiply it by 0.4%, which is this is a decimal. And when you multiply A times B times C, you can move them around, right? They're commutative. So you can really do A times C and then leave the times B. So what you're really doing is just taking this number times the first number and then readjusting. Or you can readjust your numbers and put everything in scientific notation and do this times this, and that's where you get the 23, and then 10 to the 24th times 10 to the negative 3. The rule is you just add exponents, so that's negative 21. And then you have to take this and convert it back down to scientific notation, which means the decimal always has to move to the second spot, right after the first number. So you move that over, make this number smaller, which means this one has to get bigger. So there's your final answer, and there it is with all the zeros. Now, if you would have just done 5.9742 times 0.004, you would have got a number that was smaller than 1 times 10 to the 24. You would have moved your decimal to the left, right, making the number bigger, and then you would have taken the 24 down however many times you moved it, and you would have got the exact same answer. So working with scientific notation is kind of nice, and it's just another version of, percentages, so to speak. Okay, suppose you earned a B on your last history test by getting 80% of the questions correct. If there were 60 equally weighted questions on the test, how many did you answer correctly? Well, isn't that easily just 80% of 60? And then what was your ratio of correct to incorrect answers? Well, if you got 80% of them right, didn't you get 20% of them wrong? So the ratio of correct to incorrect would be 80 to 20, which we would reduce to 8 to 2, which would reduce even further to 4 to 1. All right, so here's the work that we were talking about. Take 80% of 60. We see that we got 48 of them correct. We know that if we have 48 correct, we have 12 of them incorrect, and that reduces down to 4 to 1. Or you could have worked with the percentages like I did and still get 4 to 1. Okay, another example. Elaine was very excited to find that the watch she wanted was on sale for $66.50. The sale price indicated that it was 30% off of the original price. Let's find the original price. So if it's 30% off, that means we're only paying 70% of the original price. And this is a very important tool, guys, to help you solve these types of percent off and percent increase questions. When you take a percent off, you're basically subtracting that from 100. If you're doing a percent increase, you're adding that to 100. So if it's 30% off, you take 30 from 100, and that means you're left with 70%. That price represents 70% of what it was. I would never set it up the way the book does here with ratios. I would instead translate the words to math and say 66.5 is always equals, right? 70% of is multiplication, the original price, which is what you'd have to do with this thing to solve originally. You'd have to multiply by x to get rid of this fraction, right? Now you could technically multiply by 100 to get rid of that fraction, but this thing's going to reduce down to 7/10, which really just becomes 0.7. And that's what I would do, right? Make your life easier. We've all got calculators. We can deal with decimals, 0.7x. And now when we want to solve for x, we're just dividing both sides by 0.7. And that's how we solve for x. Here it is all worked out. You can see that the original price was $95. All right, guys, so remember, percentages and proportions are just other versions of fractions, which are also just versions of decimals. So just get comfortable with working with fractions and decimals.